everybody. I thought we'd take a moment and talk about performance. In a prior video, we created a simple Descrambler program in Common Lisp for descrambling words. Here, I'll show you what it does again for an example. I got a baseball theme in mind. I don't actually watch baseball, but there you go. And that took, in terms of real time, about a quarter of a second to do. So you may be wondering, why are we talking about performance at all? Because a quarter second isn't much time. Well, we'll get to that. I'd like to show you a couple of other things first. I do one of these words. Takes about the same amount of time. If I do two of these words, yeah, about the same. Three of them. Yeah, same all over again. What does this mean? Well, I'll show you what I'm on about. Here's our main loop for Descramble. This is going to be a bit of a review for some people who watched the first video. We first set up search keys, which is done by map carrying a reference to the function getCompareKey, which is up here. Right, getCompareKey, with the list of words that we got from the user. We open the dictionary file. We read through the dictionary file, and for each word, we call the checkWord function with all the search keys. In the checkWord function, we turn the we turn the dictionary word into a comparable key to the search words using getCompareKey again. We go through each of the search keys, and if we find one that matches the dictionary word key, we handle the matched word, which in this application is only to write it to the screen. But the reality is, for the vast majority of the words in the dictionary, we don't need to go that far. We can do a sanity check to see if the word is even worth looking at. Let me show you what I mean. I'm going to add to my let. If the incoming search words have lengths of, 4, 5 letters, 6 letters, there's no reason to look at words that don't have the same number of letters as one of the search keys. So, what we will do is we'll map car again, reference to function, length. Length is a built-in Lisp function that gets the length of a string or an array or a list or whatever you want to get a length of. Now in our loop, we can just do this. If member length dict word in search lengths, then check word. I think we're going to need one more. There we go. One more thing there. Did I mess up the syntax? We can find it very quickly by using slime. Doing the evaluation. I guess I need to start slime first, don't I? Let's not skip that step. So we started a session of Steelband Common Lisp. We don't have to look at it though. Yep, Descrambler still compiles. So now let's go to the operating system and see what the difference is. We will save that file. No killer processes will really quit. And now we'll try some of these things again. So let's try this with 4 words. Well, instead of 1/4 of a second, we're down to about half of that. Because our words, are 7 letters long, 6 letters long. There's another 7-letter word. And this one is, let's see, 3, 4, 5, 6, 7, 8. 8 letters. So we're only looking at words in the dictionary that are 6 or 7 or 8 letters long. And so we don't have to convert them all into search keys. We only need to do it for ones that have the right length. Now, let's see what effect that has when we do 1 word. Now that's a lot faster. Instead of 0.257 or so, we go to 0.057 seconds. So that's how easy it is sometimes, if you can think of a pattern, to speed things up. Guess I'll show you the function one more time. And here's the parts we added. We got a list of the lengths of the words we're searching for. And we see if the length of the dictionary word is a member of that list of lengths before we try checking the word. Why don't we do this length up here in check word? Because then I would need to get all of the lengths every word I check. And instead of doing that, we do it in the Descrambler function, so we only have to do it once. With that, here's the reasoning behind the change. It obviously works pretty well. Thank you for watching. See you next time.